Hello, guys. Welcome to another episode of Go 101. My name is Dennis, and I'm excited to facilitate this session on custom types. I hope you're excited as I am. Okay, let's get into it. So, what are custom types? Custom types lets you create your own version of a type. It's either you add meaning to a type or you add methods, or you want to improve readability or you're modeling a concept in any domain, or you're just creating your own data structure, right? So, example in computational geometry, you might want to model uh, concepts like points, lines, and polygons. And uh, the points could have fields or attributes such as the x, y, z coordinates. It could have methods such as what's the distance from my location to another location or distance between 2 points, or is this point within some other polygon? You know, all those jazz. Yeah, so with custom types, you can add meaning and semantics and all other stuff to to custom types. Okay, so in order to create a custom type, you use this built-in keyword in Go called type. So this construct here is for defining new types. And this, on the other hand, is for giving new names to the like to any type that you create or any primitive type. So this is basically an alias, whereas this is actually creating a new type. So let's try it out in our editor. I'm going to create a new project called 002 and let's cd into it. Let's initialize the Go project. Go mod init. Let's call this custom. And let's create our Go file. Okay. Do a package name. Cool. Our file name, just as we would always do. Awesome. So now let's create a custom type H, just like we see in our slides. So type H of primitive type int, right? And what can we do? Let's create a function called print h. Takes a parameter h of type h, which we have defined. Let's just print it out using the fmt package. Print line h. Very simple. Cd into 002 and go run main record. Oh, we forgot to call the function. So print h, we pass in the h argument. So let's create a type. Let's initialize a variable called h. So I'm going to do var h. First of all, let's just make it 20 and let's see what happens. So already our compiler is CLN. We cannot use h variable of type primitive int of type as h value in arguments to print h. We know what this means. It means this is of a different type to this, and so we can uh, implicitly cast this into h as you might think. So what we'll do is we will explicitly pass the type here. So we indicate the type of the h variable h, and then it works fine. So we get 20 over there. Very cool. So you can see how strongly typed Golang is over here. Now let's try out the other one. So type um, let's call this int alias census. Is going to be an alias for int. All right, very cool. Now what happens if we try to type age as int alias? Obviously It doesn't work. It's almost the same as saying age is of type int, because int alias is nothing more than an alias of int. Um, yeah, we could also do this. This also works because we've just given age an alias of int alias, and so that should work as well. So, in conclusion, using this this definition, this construct here defines new types, whereas this one gives alias to the type on the other side of the equal to sign or the assignment operator. Very cool. Now structs, my favorite data type in Go. So with structs, you can group related fields, right? So for example, for a user model, the user can have an ID, a name, an email, etc. And you might want to group them together in a model like this. Let's copy and go and paste it over, editor. Cool. So this the correct this. This is how you would define a struct. It's something similar in um, Python. Yeah, classes in Python, similar to classes in Python. So you can have, class name, the name of the identifier of the class would be user, then the class would have the self attributes, ID, name, then email. Very simple. We could have something like points, as I mentioned earlier. X, X would be, make it a float, 32. This would be Y, this would be Z. Very simple. Um, Now, another thing worth mentioning is in Golang, when you capitalize a field name, you essentially make it exportable. If you make it lowercase, then it means it's private, right? And it's not public. So capitalized means public, lowercase means private. Okay, so now that that is out of the way, let's continue. So when we do this, we essentially um, initialize them to their zero values. So when we, in our main function, let's create it quickly, create a point like this, and actually let's use user. So user, you say ID is say one, name is Dennis, and email is oxd@lazy.com. Okay, and let's store this in the u variable of app user. Yeah, let's do fmt.print line u. When we run over here, we get it printed out for us like this. What happens if we don't pass in any values? Yeah, we get the zero values. So they are initialized to their default zero values. So an integer would obviously be zero, a name would be an empty string, and an email would be an empty string. Okay, so back to the slides. So the next thing I want to talk about is methods. So just like you'd have in Python, classes could have methods. Class in Python would have the constructor method or the factory method, where it initializes the fields, the class fields, to some values. Or you could have methods that do different things in the class. In this case, we have this function here that is bound to this struct via what is known as a receiver, which I will talk about in a bit. But for now, let me just copy this method into our editor. I'm going to paste this here. Okay, so let me explain what is going on here. We have our user struct or user model, and then we have this function which is bound to the user struct via this receiver. So the way to bind functions to structs is via a receiver. So we do this and we say, so u is of type user, right? The user struct. In doing so, we are able to access the fields in the user struct. So u.id, u.name, u.email. And then when you call this function or this method on the user object, then it does whatever it does. So in this main function, user, um, we have user initialized. Let's pass in the values. So something that you typically see in Go programs is, in Python you have a constructor method. In Go you don't have that, so you typically do that yourself. So the way that you do it is by creating a function, not a method, a function. So new user, we'll call it, which would return a pointer to the user type, and we will return pointer user, then initialize or pass the values directly. So let's receive the values as um, parameters. So ID of type integer, name and email of type string. Then we pass them directly the same order in which the fields are defined. So name, comma, email. Very simple. Another way is by doing um, so return new of the user type. So this returns a pointer to user. Sometimes I do this very neat. The only disadvantage is you can't initialize the user to some values that we are passing over here. So let's just keep it as it was previously. So like this. And in our main function, what we're going to do is u is equal to new we assign it to new user and we pass in the value. So ID1, name, Dennis, then email 0xt at lazy.com. Then we just do, so let's call the method on the u object. So we're going to do u.string. We could do this, right? Yeah, we could do this. And then since it's returning a string, we could just do fmt the print line, and we do this. But I'm not going to do this yet because we don't have to do this. You could just print u, and we're going to get the format which is defined in the string function. I will explain a bit. So go run main.go, then we still get it in the same format in which we defined over here. The reason is in Go, when you create structs and you create a method like this, right? A method that satisfies the stringer interface, then in the FMT package, when you use any function in the FFT package to print the object out, you get it in this format that you defined or you described in the string method. So let's quickly jump into the FMT package. Let's go to print and look for stringer. Yeah, so this is the interface, the stringer interface. And the blueprint is that if you have a function identifier called string that returns a string, then by printing that string, by printing that object, sorry, you get the results in the same format in which you defined in the string function. Something similar in Python main notes. pi. You do like a class, then use the constructor method init, yeah, self returns none. So after self, we are expecting integer of type int, name type string, email type string, nicely. And we're going to do self that's name self id self that's name self that's email. Very simple. Now we can have this string self, then we'll do a return, then we have string user. So this would be self id, comma self name, self email. Yeah, and when we do if main, let's initialize you to user passing one, then is 0xd lazy.com, and we decide to print out u. Let's see what happens. Python 3 main.py. See, something similar to what we just did in Golang. Instead of running the Go program, instead of running the Python program, we run the Go one. Then we get this. Very cool. If you're not very clear on interfaces, don't worry. We'll cover interfaces in our next episode. But for now, I'll try to grasp what is going on. Yeah, so that's how you typically implement methods in Go and bind them to structs via receivers. Back to the slides. Yeah, so another thing I want to talk about is value receivers versus pointer receivers. So what we defined, the method we defined in our code, we have something like this. And what this means is this is a value receiver. In other words, it is not a pointer. And so when used or when you try to modify a field in the user object or the user itself, it wouldn't work because you're merely operating on a copy of the object and not the object itself. On the other hand, if you define it as so, this is a pointer receiver. If you try to make a modification, it is going to affect the original object, right? So if you create a type based on a struct, it is going to affect the struct. Based on the slice, it is going to affect it. And some other data types. Okay, so when you use which, you use value receivers when you're not making any modifications to the object, or you're just reading from the object. You don't or you don't care about the copying overhead when you use value receiver, and you use a pointer receiver when you know you're going to make a modification to the object, or uh, there is going to be much of an overhead when you copy, right? So that's basically the difference. So let's try to prove that. I'm going to create a new function or a new method called, let's first bind it to user via a receiver called change name. So change name would obviously take a new name param. So new name, I'll just name a type string, which we just do a u dot name equal to then the new name. Very simple. Now over here, I'm going to do u dot change name, pass in the new name. Let's call this compiler, and we will then do fmt print line missing 10. Oh yeah, we don't have to return anything here. Good catch by our compiler. So now we tried to override the name, right? But it didn't work. We are still seeing Dennis, even though we are changing it to compiler. And the reason is because we're using a value receiver. Now what happens if we make it a pointer receiver? Now that works because it will affect the underlying or the original object. Now back to the slides. Let's move on to function types. So just as you can um, create custom types based on structs or on primitive types, you can do same with functions. And you do same with the type keyword, the name of the type, the custom type, and the built-in type. So let's just copy these and paste them in our editor. But first, let's move the user stuff into a new package called user.go. Um, package user, and go back to main, copy everything here into user.go, delete the main. Okay, we're good to go. So we go back to main.go and clear out everything here. Find main. Okay, copy and you paste. So we have it formatted nicely for us over here. Our first custom function is called int_mapper, which is based on this function. Takes a parameter of type integer, returns an integer, and this int predicate takes a parameter of type integer and returns a boolean. So what we're going to do is something similar in the JavaScript ecosystem. You have something like array.map, then the current value, you do something to it, you transform it, say v times v if they are numbers. So squares of uh, the numbers in the array, and then it returns a new array. Yeah, something like this. So this is what we're going to try to achieve. And for the second function over here, that would be for filter. So the predicates would be if maybe v modulus 2 equals 0. So if v is even, then filter it out. So we're going to try to achieve these. Okay, this should be fun. Now let's comment these out for now. So in our map_int function, what we're going to do is iterate over the input slice. So we're going to do a for the index, and let's call this I, so the integer itself, range over slice. Okay, so what do we want to do? Over here, we want to then call the function, or in this case, a callback, and pass the value I, and the result would be an integer according to our definition over here. So an integer, the result of the function call, we would want to store the result in a new slice. You don't want to modify the slice from which you're reading. So let's create a new slice called out. Then we make it make a new slice, integer slice, and set the size to be equal to the length of the input slice. Yeah, because they are going to be of the same size. So then we do an out at this index is equal to the result of the function call, the callback. Okay, then we finally return out. I hope, yeah, that should work. So what we're going to do is initialize a new slice called in slice int mm, int slice. Bad typing today. So int 1, 2, 3, 4, 5, and we'll call map int, pass in the slice. The second is the function. And we could create an anonymous function directly in here, or we could go and create a function of the type int mapper. But let's just keep things simple. Create a function over here. So func that satisfies the type map int mapper. So func takes in the type int, returns an integer. Then we define the function. We make it return. It should be a parameter name here I. To return I times I, which is what we want. In slice. Let's rename this in slice. Okay. Now the result, let's call it out slice. Then we are going to print out the out slice. Hopefully that works. Yes, and that works nicely. So squares of the numbers in the input slice. Very cool. So we've achieved that functionality. We could also quickly do same for the int predicate. So I'm going to uncomment this, and we will work on the function body for this. So it's going to be pretty similar. So let's copy the contents in here over here, and let's change some stuff. So over here, the result of the transformed array isn't, the length of the transformed array isn't going to be equal to the length of the input slice. So no need to pass this. You could just do this and make it, 0, but let's just keep it simple and do this. So int, oops, let's do this, and we are going to still iterate over the slice. Over here, this is going to return a boolean. Let's store the boolean here. So if the predicate evaluates to true, let's say if the current value is an even number, what do we do? We want to check if true. So if true, then we want to no, let's check if not true, right? If not true. So if it's not an even number, then we are going to do an out at this index. In fact, we could just do an out. So out of append should do this for me. Yeah. So append then I. That should work. Else we don't do anything. We essentially just do nothing. At the end, we return out. But my mind is telling me we could simplify things over here. Let's do this. Okay. Yeah. So let's go over again. we initialize our out slice and we range about the slice. We check if the boolean value is false, so the predicate is also false. Then we append the value to the slice. We don't do anything if it's true, and we return it. So let's try it out. Hopefully that should work. So out filtered, let's call this out filtered map, what's it called, filter int, passing in slice. So func takes in an int, returns bool, returns a bool. Then we are going to do return I modules 2. See if the number is an even number. Filter it out. I'm going to just keep the odd numbers. And let's print out the filter. Hopefully that works. Cool, and that works as we expected. So we have 1, 3, and 5, which are our odd numbers. Pretty cool, right? Yeah, you could try out the reverse and what's the other one called? Those other higher order functions. You can try them out. These don't come out of the box in Golang, so you get to implement them yourself and feel smart about it. Okay. Yeah, you also get to create custom data structures in Go using custom types. So let's try to quickly implement this. Let's create a new package for that. Let's call it store go package store. Copy, paste. Okay, so what we're going to do is create a custom type name store based on the map type. Now the map is already a reference type in Go, so we don't need to um, in the methods in the receivers make them um, a pointer receiver. A value receiver would suffice since a map is, a reference type in Go. Okay, so we create our type store based on map key string value string, and this method is going to be essentially adding a key and value pair to the map or to the store. So we're going to do so in order to access the store itself, you this gives us access to the store itself, right? So if this was a struct, then you do an s dot in the field name, but the s here would be the map itself, the store. So we do an s, then the key, set it to the value. And that should store the value to the key. Very simple. And the next method would be get. So in getting, you do your s dot the key, s dot the key, then we get the string and the string if the value exists, and a boolean depending on its existence. So we get val, then okay, so okay for the boolean. Okay, and then we just return val and okay. Lastly, then delete. So we do delete, pass in the type, which is s, the map, and then the key, whose value you want to delete, key. Simple. So if it doesn't exist, nothing happens. It's a no operation. and we are going to go into our main file, main.go. Let's clean things up a bit, and file name. Oops. Let's import the store, the name of the module first in store. Then we do a store. That is if um, yeah, in fact, let's create a factory method for it. So find new store. This returns store. We're just going to do a return make of store. Very simple. To essentially initialize the map. So store dot new store, which returns a store. Let's call S. So let's try out the methods on the store. So store dot puts takes a key, name, value, Dennis. Paste this a couple of times. Age, say 29. I'm not 29, by the way. OS, Windows, get it, Linux, and hobby, hobby. Let's say gem. Okay, and now let's first print out the map in the store. Yeah, so we get the map over here nicely. How do we get s.get? Then the key, let's get the value for the OS, which returns a string. So let's call this value, then okay. Then we check if okay, then we're going to print. But there's a convention in Go that you'd see a lot, which is if this, then okay. If it's okay, continue to print line the value. But if it isn't okay, else, then we're going to print and say no key exists. Very simple. Oh, there's a typo here. Okay, cool. So we get Linux as we expected. And let's pass in something that we don't have a key for. So say what else? What food? We get no key exists for that. Very cool. So we've successfully created our own custom, lazily created our own hash table or hash map, which is based on the uh, map primitive type in Golang. Very cool. You could also tweak this to make it work as a set. We could try doing that, but for the sake of time, we would just leave it for another time. But you could make it such that this returns extract, right? Extract, and in initializing or in setting a value, you just do okay. So value would be of type struct, and this would be of type empty struct. Right? This is essentially saying set it to nothing. Empty struct has no value in memory. Yeah, no, it doesn't take any memory. And yeah, my bad. So this would be value. My bad. And this would still be key. But yeah, you get the whole flow. Whenever you want to set it, um, whenever you want to set a value in the set, you set it to an empty struct so that doesn't take space. And for now, this is our store implementation. Back to the slides. This brings us to the end of this episode, and I hope you had fun as much as I did. Okay, okay. Yeah, so thank you guys for joining. Um, we meet you same time next week. Enjoy.